So sometimes you're going to get questions where they ask you to find the equation of a line, whether it's leaving your answer in standard form or slope-intercept form, and they give you 2 points, but they don't give the points like 2, 3, and 6, -5. They give you like 2 intercepts. So for example, if we had to find the equation of a line and leave it in standard form, and let's say the x-intercept is 2 and the y-intercept is, I don't know, 3, let's just say. Then what we would do is we would go to our graph. I mean, you don't have to do it with a graph, but I'm just going to give you an explanation with the graph, and then we're going to solve it graphically, and then we're going to solve it algebraically. So I know, like, good times, right? Okay, so here I've given my scaling, I've arrowed and done my x and y, I'm all good. So now, given, I'll call this given intercepts. So let's plot these points. The x-intercept is 2. The y-intercept is 3. The line looks like this, right? So the x-intercept is 2, the y-intercept is 1, 2, 3. And now we need to find the equation of the line and put it in standard form. Just because. No reason, I just made up the question to be like that, standard form. So what we need to do is we need to y equals mx plus b. We know the y-intercept is 3. We know the slope is, well, let's see, slope from here to here is rise 3, run 2 to the left. Rise 3, run 2 to the left. And now we need to put it in standard form because we weren't asked to leave it in slope-intercept form. So first thing we do is get rid of our fractions. So we know already how to get rid of fractions. We've done this in previous chapters. We multiply everything by the lowest common denominator, in this case 2. So that would make this times 2. 2 times this gets rid of that 2, and 2 times this is that. And then we're going to bring everything over here so that a is positive, the coefficient of x. So I've got 3x plus 2y minus 6 equals 0, because that changes sign and that changes sign when I bring it over, and then I put it in x, y, constant equals 0, and I'm done. Ba-boom! Okay, now let's talk about not using a graph and just using algebra. So we're going to write it on graph paper anyhow. So here is graph assisted, and here is algebra assisted. So if we have the points x-intercept is 2 and y-intercept is 3, well, hold on a second here. If the x-intercept is 2, doesn't that mean that the coordinates of that point are 2, 0, right? 2, 0. That's what that is, right? So that means the point is 2, 0, and this point is 0, 3. Because we know to find the y-intercept, x is 0, and to find the x-intercept, y is 0. So there it is. X-intercept, y is 0, y-intercept, x is 0. So now I'm going to do slope equals y2 minus y1 over x2 minus x1, and that is 3 minus 0 over 0 minus 2, and that is 3 over negative 2, right? 0 minus 2 is negative 2, so I put the negative there. And, of course, we already knew this from doing it with graphing. The slope was negative 3 over 2. So is this more work than just looking here and doing rise over run? Yeah, I guess a little bit, but whatever. That's what they want us to do, so that's what we do. So here's our slope, and then we have a slope, and we can pick any point. So we did y equals mx plus b up here, so I'm going to just, for variety, do it with this. So if I use slope is negative 3 over 2 and the 0.03 are what I'm using here for this, then I've got y minus 3 equals m x minus x1, and that is y minus 3 equals negative 3 over 2x. Got to multiply both sides by 2, which is the lowest common denominator. 2y minus 6 equals negative 3x. Bring negative 3x over. I have 3x minus 2y plus 6 equals 0. And yes, of course, 3x plus 2y. Wait a second. I made a mistake. The 6 didn't move and the 2y didn't move, so they stay like that. 3x plus 2y minus 6 equals 0, and 3x plus 2y minus 6 equals 0. There you are. Algebra, graphing, it's all the same. Two roots to the same place each and every time.